Welcome to this explainer. Today, we're doing something a little bit different and honestly incredibly exciting. We are decoding a highly specific but absolutely crucial strategy for your exams, mastering fractions with denominators of 2, 3, 4, 6, or 8 in Cambridge Igcse Additional Mathematics. Now listen, if you are currently grinding through past papers and preparing for subject code 0580, 0606, 4024, 4037, or 4040, you are exactly where you need to be right now. Grab a notebook, because we're about to deconstruct real examiner reports. We're going to build bulletproof mathematical arguments that are fully stress-tested against the toughest grading rubrics out there. By the time we wrap up this session, you aren't just going to be calculating answers like a robot. You're going to be engineering perfect, high-level responses that Cambridge examiners absolutely love to see, and more importantly, love to reward with maximum marks. Let's establish the stakes right away, because they are incredibly high. As senior examiners point out, and this is a direct piece of insider intelligence, this highly specific syllabus point is frequently the ultimate gatekeeper. It's the wall separating average, middle-of-the-pack grades from top-tier A-star success. To truly understand this, let me introduce you to two archetypical students that we see in the examiner data every single year. Let's call them Alex and Sam. Put yourself in their shoes for a second. You flip open a real Cambridge mathematics past paper, maybe a brutal paper for code 0580. You're confronted with a complex equation involving these exact fractions. Maybe it's an exact trigonometric value in radians, like pi over 3, pi over 4, or pi over 6. What does Alex do? Alex panics and overloads the page. We're talking a massive data dump of raw mathematical facts, formulas scattered everywhere, providing absolutely zero analytical structure. It's a mess of numbers. Then there's Sam. Sam is the sprinter. Sam rushes the calculation, completely misses the critical command word in the prompt, words like show that or hence, and just slaps down a final rounded decimal answer at the bottom of the page. Imagine their papers side by side, just covered in red pen marks from the examiner. They both lose massive points. But here's the kicker. It's not because they're bad at math. It's because they simply don't understand the strategic game of Cambridge exams.
To give you a comprehensive blueprint to completely avoid the fate of Alex and Sam, today's masterclass is structured into 4 absolutely crucial parts. First, we'll hit the core principles. Then we'll dive into our step-by-step methodology. After that, we'll uncover some critical examiner warnings, and finally, we'll wrap up with evaluative thinking and problem solving.
Let's jump right into part 1, core principles, and how we set the academic benchmark. The very first thing you need to realize is that every single question you face is governed by a command word. We're talking about words like evaluate, simplify, derive, or solve. Understanding exactly how those command words dictate your use of specific fraction denominators is literally your absolute first step to academic mastery. If you don't decode the command word, you're flying blind.
This comparison perfectly illustrates the massive mindset shift you need to make today. You have to move away from superficial breadth. That's Alex's strategy, right? Memorizing disconnected facts without truly understanding their deep application. You must fundamentally shift to analytical depth and logical structured reasoning. Let's really think about this for a second. When Cambridge specifically restricts a syllabus point to fractions with denominators of 2, 3, 4, 6, or 8 only, they aren't just picking random numbers out of a hat. They are testing a very specific bounded logic. Think about the math here. Denominators of 2, 4, and 8 consist solely of prime factors of 2. What does that mean in the real world? It means they will always produce neat, tidy, terminating decimals. 1 over 8 is 0.125. It ends. But denominators of 3 and 6, they introduce the prime factor of 3, which leads to wild repeating decimals unless they're simplified perfectly. Examiners want to see if you possess the analytical depth to recognize these properties and manipulate them accurately, rather than just mindlessly plugging numbers into a calculator and hoping for the best.
The syllabus makes it crystal clear that truly mastering these restricted denominator fractions requires a connected conceptual understanding. An understanding so solid that you can confidently apply it to completely unfamiliar contexts and curveball problems. So how do we actually demonstrate this on paper? We do it by adapting a framework that is usually reserved for heavy essay subjects like history or English, but which actually acts as an absolute secret weapon in advanced mathematics. It's the PEEL framework, P-E-E-L. Point, evidence, explanation, link. For a complex math proof, your point is clearly stating the theorem or formula you're applying. Your evidence is extracting the specific fractional values, those 2s, 3s, 4s, 6s, or 8s, directly from the prompt. Your explanation is your meticulous, step-by-step algebraic manipulation. And finally, your link states clearly how your derived expression satisfies the exact command word of the question. Top-performing students don't just do math, They essentially write a perfectly structured argument using numbers and symbols. Before we continue on to the specific methodology, subscribe to our YouTube channel, Ace the Exams at acetheexams_Igcse to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's move into part 2, the step-by-step methodology. Now that we understand the analytical mindset and the power of the Peel framework, let's see how this builds into the exact procedural steps to systematically dismantle and solve these problems under pressure. Listen closely, because this is arguably the most valuable piece of strategy in this entire explainer. The secret to unlocking high scores is aggressively leveraging the method mark strategy. You have to recognize that examiners heavily reward your logical process along the way, not just the final number at the bottom of the page. Remember our two struggling students, Alex and Sam? Let's do a live rewrite of their answers right now. Imagine we're taking a red pen and transforming their mistakes into green check marks. For Sam, who rushed straight to a decimal answer and got absolutely 0 marks, we forced a change in strategy. The question asks for an exact value using fractions with a denominator of 6. We force Sam to stop, breathe, and write down the intermediate substitution step clearly. Bam! Just like that, an M1 method mark is secured, even if Sam's final calculation goes completely off the rails later. Now for Alex, who wrote that messy, chaotic page of identities. We apply the Peel framework. We cross out all the irrelevant formulas, organizing the logic cleanly so the examiner can easily follow the sequence. The final A1 accuracy mark? That's just the cherry on top. The true mark potential, the bulk of your grade, is built entirely in the method. Every single time you tackle these specific fraction problems, you must consistently execute this exact 5-step procedural framework. Let's practice this right now, together. I want you to imagine a complex question involving the binomial theorem. Step 1. Deconstruct the question. You scan it and see the command word is find the coefficient. Okay, locked in. Step 2. Extract relevant data. You look at the powers involved, and they give us fractional indices with denominators of 2 and 4. Step 3. Select the analytical framework. Based on the data, we know we need to use the general term formula for binomial expansion. Step 4. Execute with clear notation. Now, this is exactly where most candidates fail. You absolutely must clearly separate the numeric fractions from the variable powers. Keep them distinct. Step 5. Present with correct terminology. State the final coefficient clearly and make sure it is fully simplified. If you can train yourself to execute this blueprint within a 60-second window of first reading a question, your cognitive load drops massively and your accuracy shoots through the roof.
You also have to keep in mind that presenting your work follows incredibly strict conventions. Ignoring proper headings, lacking clear annotations, or botching the exact terminology will cost you heavily, even if your underlying math is solid. When dealing with denominators like 3 or 6, a classic, devastating trap is rounding too early. The appropriate format convention, the golden rule here, is to keep everything as an exact fractional value until the absolute final step of the problem. If the question states, give your answer in the form A over B, and you write a decimal, you have failed the presentation convention. You get docked, regardless of how brilliant your earlier method was. Clear annotation means communicating with the examiner. A simple, quick note like substituting equation 1 into equation 2 acts as an insurance policy, saving you from losing marks if your algebra gets a little messy down the line. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_Igce to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_Igce and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, welcome back. Let's dive into part 3, critical examiner warnings. We are going to leverage insider intelligence taken directly from the principal examiner reports to uncover the critical, grade-killing traps that sabotage the majority of candidates.
According to the hard data from the Cambridge examiners, there are exactly 3 major mistakes that get flagged year after year on this exact topic. We're going to do a quick data scan challenge right now. I want you to imagine putting 60 seconds on the clock and looking at a massive chart of examiner trends. If we scan that data, the core trend becomes glaringly obvious. Candidates are actually losing marks not on the complex, high-level calculus, but on basic foundational fractional arithmetic errors at the very end of the problem. They do all the intense heavy lifting, but then they stumble and crash when they simply have to add a fraction with a denominator of 3 to a fraction with a denominator of 8. It's heartbreaking, but it happens constantly. Let's look at these 3 specific mistakes in detail. Because to protect your grade, you have to guarantee your answers are highly specific, flawlessly formatted, and directly tied to the context. Let's play a little game, Find the Flaw challenge. Listen closely to this flawed sample mathematical conclusion. The distance is 5.33 because I divided by 3. Okay, what is the flaw that loses marks there? Did you catch it? The flaw is actually mistake number 1 and mistake number 2. It's way too vague and the format is completely wrong. The examiner commentary for an answer like that would aggressively state that the candidate failed to leave the answer as an exact fraction, such as 16/3, and provided a rounded decimal without any justification. To fix this, let's use a 30-second speed writing approach and rewrite it using our Peel response. Here we go. Point: apply the distance formula. Evidence: substitute the coordinates containing denominators of 2 and 4. Explanation: simplify the resulting surd meticulously. Link: therefore, the final exact distance is exactly 16/3 units. Boom. That is how you guarantee maximum marks and leave no room for the examiner to dock you. Furthermore, an absolute non-negotiable rule is to clearly define your mathematical terms before deploying them in your extended responses. There is a huge hidden danger here regarding terminology confusion. For instance, when a question specifically asks for a rational denominator and you casually leave a surd, a square root, in the bottom of a fraction with a 2 or a 6, you are showing the examiner you don't know the terminology. You must explicitly demonstrate the procedural process of rationalizing the denominator. Similarly, if the question asks for exact values, writing down 0.866 instead of the exact fraction root 3/2 is a fatal error. It shows you aren't fluent in the examiner's language. Now, if you are someone who struggles to retain all these strict formatting rules, I want you to try utilizing a memory hack called the visual story method to creatively encode these denominators into your long-term memory. Try this. Imagine the numbers 2, 4, and 8 as neat, tidy little cardboard boxes. Because they are powers of 2, they always terminate cleanly. They pack away nicely into a perfectly sized box. But the numbers 3 and 6, imagine them as wild, endless, repeating loops of string that simply refuse to be boxed in. By creating this kind of mental visual story about how these numbers behave algebraically, you will instantly know, even during the extreme stress and time pressure of the actual exam, whether you should be expecting a clean decimal or whether you absolutely must leave the answer in exact fractional form to preserve its integrity. This type of cognitive anchoring works absolute wonders when the clock is ticking.
Finally, let's move into part 4, evaluative thinking and problem solving. This is where we elevate your approach from just good to the top-scoring A-star evaluative mindset required for the most complex, unstructured parts of the exam.
When a tough, high-value question demands comparative analysis involving these fractions, say, perhaps asking you to compare the gradients of 2 perpendicular lines where one has a fractional gradient, you must rigorously highlight both similarities and differences. And you do this by using strong comparative connectives supported by hard mathematical evidence. This really brings us to the ultimate summary of the techniques we've built today. There is a final system consisting of 3 unbreakable rules that guarantees top marks on these papers. Rule 1, command word decoding. You must know, in your bones, exactly what evaluate versus simplify means. Rule 2, PEL framework application. You have to structure your mathematical working as a clear, logical, undeniable argument. Rule 3, the time management matrix. You must let the allocated points dictate your time. Do not spend 10 minutes sweating over a 2-mark fraction simplification, and conversely, don't rush a massive 6-mark comparative proof in 2 minutes.
Navigating completely unfamiliar, curveball problems at an A-star level requires utilizing a continuous deconstruct, solve, evaluate loop. This is how you systematically verify the reasonableness of your calculations in real time. As you work through the logic of a problem, you must always pause at step 4, check for reasonableness. If you're calculating a probability, for example, and your fraction with a denominator of 8 somehow ends up being greater than 1, well, your loop should catch that fatal error immediately before you stubbornly move on to the next page. Students who diligently implement these highly structured mathematical strategies and routinely use the Peel framework see absolutely massive improvements in both their speed and their accuracy.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but that only happens if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. As you implement these exact strategies into your daily study routine, I want you to ask yourself this final critical question. Are you actively questioning assumptions, considering different perspectives, and justifying your mathematical decisions with concrete evidence? Don't just sit there and do the math. Engineer your mastery. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to absolutely every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.